In this video I'm going to show you how to work out the equation of the tangent line and the equation of the normal line for this graph at this given point right here. So the point here, the point here is given by a comma a to the power of a. So if you jump to Desmos, it will look something like this. See this point here is a comma a. So as you slide it, it will draw the tangent line and the normal line. Okay, so our aim is to find those two equations. So jump back to here. If you want to find out the equation of this tangent line, well, this is a straight line, so any straight line would be of the form y equals mx plus c. We need to know the gradient. So the gradient, if you want to know the gradient of this, you would differentiate it. So to differentiate this, take the natural log of both sides. So natural log this side, natural log of this side. When you natural log this side, this x is able to come down, and then you have your natural log of x. So from here, take the natural log of both sides. That will then give you this. And then now use implicit differentiation. So this is like a bubble here. Remember, y is a function of x. So when you differentiate this, it will be 1 over y. But because y is a function of x, you need to stick dy by dx in there. And then this thing here, this is a variable. This is a variable. So you've got to use the product rule. So the product rule is you differentiate the first, leave the second alone. So that will then give you this. And then plus, leave the first alone, differentiate the second. When you differentiate the second, it's 1 over x. Leaving the first alone is x. And then this x gets multiplied to the top, giving you this. So now we are currently here. Remember, we want to work out dy per dx. We want to get this on its own. So from this, multiply both sides by y. So that will then, this thing here becomes this. And when you multiply by y, it will then give you this thing here. So dy by dx is given by this, but we don't want the answer in terms of y. So we would go back to here. You see, y is this thing here. So put this back into here. So that will then give us the gradient. So the gradient is given by this. But remember, this gives us the ability to work out the gradient anywhere along this graph. But the thing is, we want the gradient specifically at a. So we would put a into here, and into here. So that will then give us the gradient at this point here. So hang on. So when you put a into here, and into here, it will then give us this thing here. So remember, the equation of our line is y equals mx plus c. Well, we now know the gradient at that given point. This is our x here, and this is our intercept here. So we are now currently here. So the equation of this tangent line is given by y equals m. This is our m here, the gradient, x plus c. But the thing is, we still need to work out the intercept. The intercept is here, but we don't know where this here is. We've got to work out that here. So so this is our x location. This is our y location. So to work out the intercept, we need one specific point on that line. Well, we know the coordinates here. It's a comma a to the power of a. So we would put this a to the power of a into the y. That will then give us this. And then put this into the x. And then later work backwards to find c. So when you put this into the x here, that will then become this thing here. So this is our gradient. And this is our y here. So now we are currently here. So now it's merge these two together to give you this. And well, c is given by this thing here. So you take away this whole block from both sides. That will then give us c. So now the equation of that line, of that tangent line, is given by this. So if you jump to Desmos, and you start out by so jump to Desmos, start out by punching this in. So that will then draw your graph. And then the next step is you add your point. So add this point here. and then you can slide it back and forth. And then the equation of our tangent line is given by this. So that's our tangent line. So now we need to work out the equation of the normal line. So going back to here, we've got our tangent line. We now need to work out the normal line. Remember, the normal line is you taking the negative reciprocal of the gradient. So if hang on. So we've got hang on. So we've got the equation of our normal line. If you want something that's perpendicular to the tangent line, you would have to take the negative reciprocal of this thing here. Well, the negative reciprocal of that thing is given by this. So our normal line is given by this. So hang on, the equation of our normal line is y equals a different m x plus a different c. So now if you want to find out the gradients for this normal line, you would take the negative reciprocal of this. So taking the negative reciprocal of this will then give you this, and then you've got your x and then plus c. Remember, this c is different. This c is up here as opposed to down here. So we need to work out c now. So we've got the gradient of our normal line. We've got the gradient. The gradient is given by this. So now we need one particular point on that line. Well, we know this point here. This is our x. This is our y. So put this into the y, put this into the x, and then work backwards to find c. So now, if you put this into the x, this gets multiplied to the top. That will then give you this. Put this into the y. That will then give you this. So now c is given by this thing here. So now you can hang on. Let me think. What did I do? This is our c. So the equation of our line is given by this thing here. Okay, hang on. Let me take it one step back. Mx plus c. We know the m already. This is our m here. 1, and then this is our x here. This is our x here, and then this is our c. This whole thing here is our c. Okay, so the equation of that normal line is given by this. If you merge these two fractions together, that will then give you this, and then plus a to the power of a. So now jump back to Desmos, punch this in, and then it will give you your normal line. Okay. So the equation for the tangent line is given by this thing here. The equation of the normal line is given by this thing here. Okay.